VS Series Grayscale Blob Tool. The Grayscale Blob tool detects clusters of lighter or darker pixels by comparing the average intensity of smaller segments within the region with the overall background reference intensity. It will count the number of blobs and measure the characteristics of each, such as volume, center of gravity, area, roundness, perimeter, and major and minor axes. Connect to the Grayscale Blob simulator and play through the images. These test images will be used to explain the main settings of the Grayscale Blob tool. Start with image number 1 in the film strip and add the Grayscale Blob tool from the flaw detection category. Draw the inspection region around the image area. The detected blobs will be indicated by a minus sign or a plus sign. The minus sign indicates blobs that are darker than the background, and the plus sign indicates targets that are brighter than the background. You can see right now it is only detecting 10 of the blobs. That is because the detection count, as a default, is set for 10. Under blob settings, change the detection count to 12. This is the maximum number of blobs or targets to detect. The contrast view in the image viewer will show a heat map of the detected objects, and it's color-coded with the smaller amounts of difference shown in blue, then ramping up to green, yellow, and then red, depending on the difference from the background. The Grayscale Blob tool will break the inspection region down into many smaller areas called segments. It will detect the average intensity in each segment and compare that to the background reference intensity. Segment size dictates the size of the individual segments. As a default, it is set for 16, which is a 16 by 16 pixel box. This can be changed as needed. The segment interval is automatically set so that the segments are overlapping. This could be manually set as needed. In high-speed mode, the segment size is adjusted in increments of 4. If high-speed mode is turned off, you can freely set the segment size all the way down to 1. Setting it to 1 will give you a more true pixel size of the objects. Set the segment size according to the application. The smaller the segment size is, the smaller objects it can detect. For this example, we'll leave it at 1. Detection target will dictate which type of blobs or targets will be detected. As a default, it's set for bright and dark, but it can be set for just bright, which will detect only the objects that are brighter than the background, or it can be set to dark, which will detect just the objects that are darker than the background. Reference intensity is the value that the average intensity of each segment is compared to. As a default, it is set to median, which is the median value of intensity throughout the whole region. It could also be set for average, mode, or you could specify a value that you would like to compare to. Detection threshold is the minimum difference from the background that the segment needs to be detected as a blob. So if the average intensity of the segment has a difference of 10 or more from the background, it will be detected. We'll leave that at 10 for the moment. Detection order determines how the blobs will be numbered. As a default, they'll be labeled as area descending. So the largest object will be the first one, which is target 0, and then numbered accordingly. Let's set this to y greater than x ascending. So basically they'll be numbered left to right. The results of the tool are displayed down in tool results. Detected intensity difference is basically the biggest difference it found of intensity change. The reference intensity is displayed as well as the total area and total volume, the count, and you can get the characteristics of the detected blobs. Right now it's displaying the results of the judge label, which is target 0 in this case, and that can be changed as needed. The individual results of each detected blob can be displayed in label results. The fill hole setting is on as a default. What this setting does is if you have a donut-shaped object like this target 0 here, it considers it filled in as far as like the size and how it analyzes it. So for example, the area of this blob is now about 13, a little bit over 13,000, as you can see with the fill holes on it. If we turn the fill holes off, you can see the area drops to about 9,500. So that setting can be turned on and off as needed, but it is on as a default. The filter settings can be used to filter out any unwanted blobs based on the different characteristics, such as area, volume, etc. So for example, area, which is the size of the object. If I go to the labels results here, and if we filter this list to the items that contain area, we can take a look at the various areas of the or size of the objects. So if we wanted to filter out everything except for the larger blobs here, as you can see, we could put a lower limit of about 11,000, and you can see it will eliminate all the objects that have an area that's smaller than 11,000. Another characteristic available with the Grayscale blob tool is volume. It's kind of like a grayscale volume. So each object, it adds up the differences of each of the segments for each detected blob and gives you a volume. So the more difference it is from the background, the higher the volume will be. So if we sort those objects by volume, let's take a look here. Again, we'll filter out this list to look at just the volume items. We can see the volume of these targets that are being detected. So you can see these are much more difference or change than the background than the other ones. So the lowest one here, you can see has a value of about 219,000. So if we wanted to filter out lower volume objects, we could put a tolerance or a lower limit on the volume. So if we put a lower limit of 900,000, we can eliminate all the other targets and only concentrate on the ones that have a high volume. So you could filter out the unwanted detections on these using these filter settings. For now, we will clear these back out so we are detecting all the objects. Note that the area lower limit default is 100 to eliminate any noise less than 100 pixels in size. Another blob characteristic that can be used is called roundness. Roundness is a factor from 0 to 1. The closer the object is to a perfect circle, the closer the number is to 1. So if we filter these labeled results down here by roundness, we can take a look at the roundness values. So you can see the roundness factor for all these detected blobs. The longer skinny objects have a much smaller roundness factor here. So we could, if we wanted to filter those out, we could easily filter those out with the roundness filter. So if we put a lower limit of 0.7, so anything with a roundness less than 0.7 gets eliminated, we can eliminate the targets that are not very round. On the other side of things, we can go the other way. If we wanted to eliminate the objects that are round and only concentrate on things that are less round, we can put an upper limit on the roundness. So now we put this to 0.7, we can eliminate all the objects that are more round and only concentrate on the ones that are less round. So depending on the situation, the filtering conditions here can be handy. Another common parameter that is available is major axis and axis ratio. Now as a default, it is not activated. To use the major and minor axis ratio, first the angle range would need to be turned on. So you can turn the angle range on, and then you can enable those settings right here. And when they're enabled, you also have the axis ratio, which is the major to minus axis ratio, and then the major axis is available for filtering and also available as results in the tool. Let's test out image number 2 in the film strip, and you can see we're getting some misdetection here because the background is a little uneven. We'll take a look at the contrast image to view this. So what we can do in this scenario is one thing we can do is adjust the detection threshold. So we can raise that up. So if we raise this up to about 45, you can see we've eliminated that uneven background detection and are correctly detecting our objects now. So now the detection threshold is 45. So the difference between the average intensity of the segment and the background needs to be 45 or greater to be detected. Now let's go back to image one, and you can see we are now missing some of our detections after we made that adjustment. So if I change to the filtered image, you can see we're not detecting these lower contrast edges. So what we can do in a scenario like this, where you need two different thresholds, maybe one for the dark, one for the bright, is we can change the detection target to individual. And this allows us to have a separate detection threshold for the bright objects versus the dark objects. So for the brightness, maybe we need a little bit lower setting. So we can set this to 20, for example, and now we're getting all the detections properly. So it is possible to have a separate threshold for the brighter targets and the darker targets if need be. So now if we go to image number 2, we are now getting some, now that we adjusted our brightness threshold, we're now getting some detections around the corners here. What we can do in this case is go to the blob settings here, and there's a setting called active border. If we turn the active border on, it will eliminate any of the blobs that are touching the region here. So these are not fully inside the region, so they're not being detected. So the blobs have to be fully inside the region to be detected if the active border setting is on. Once you have the desired detection conditions set, you can then set your judgment limits on the tool, the pass-fail criteria. So you can set a judgment condition on the count, area, and volume, as well as the other parameters. As a default, those other parameters are hidden, so if you click this button here, you can activate and display any of these parameters to be able to set a limit on. So for example, if we wanted to set a limit on perimeter, we could check this box to enable it, and then we can set an upper or lower limit on the perimeter. Now, if you notice, there's only one value for each, the area, volume, perimeter, etc. So as a default, the limits only apply to the judge label. All right, so if we go back to detection, under judge label here, you can see it's specified and target 0. So right now the limits are only applying to target 0. But if we want it to apply to all the detected blobs, just set this to all, the judge label type. And if we go back to judgment, you'll now see a max and min for all the various parameters. And now you can set an upper and lower tolerance or limit on any of the desired parameters.